So let's look at this question. So determine the sampling rate of a band limit signal whose lower frequency is 50K and the upper frequency is 67K. Okay, if we draw the frequency domain representation of this one, you can find, for example, we said here is 50K hertz. So this is lower part, and we see here is the 67K, which is the upper part. Okay, let's assume this signal look like this. Okay, give a arbitrary shape for that. So we assume that. So conventionally, if you use the convention sampling theorem, so what is the sampling frequency? So sampling frequency is double the maximum frequency. All right. If we want to sample a signal with this frequency spectrum, we can see the maximum frequency is 67. All right. So we're gonna do 2 multiply 67K. That is 134K. Okay, that's the answer. All right. But you can see there are a lot of space that just doesn't have stuff. So if we use 100 plus K is pretty wasted. So now we introduce in the class, or even actually introduce a new theorem. It's called a bandpass sampling theorem. So the theorem is sounds like this. So the equation look like this. So 2fh over n, and then the sampling frequency is in between these two numbers. So basically, we are saying when the higher boundary is a multiple times of bandwidth. So this is the bandwidth. If it's the multiple times of bandwidth, it's the integer of multiple times of bandwidth, then the fs is actually just double the bandwidth. All right, so that's the theorem we're going to use to do that. What I mean by multiple times of bandwidth, let's look at an example. Say, good. No, see, we have a row. Okay, we have axis, y-axis, and say if we have a 50K hertz lower bound, but we have a 75K higher bound. Say we have another shape, something look like this, any shape. What the bandwidth for this one? So the bandwidth is high or upper, lower, that's the same, high and low. Okay, so we're gonna use 75K minus 50K, that is 25K, and the upper bound divided by bandwidth is 75 divided by 25 is 3, and the lower frequency divided by bandwidth is 2. Okay, 2 times. So this is a perfect integer multiple of bandwidth. So the frequency, sampling frequency for this particular signal, this is the frequency domain representation, we can just use 2b, which is 2 times 25 kilohertz, then it's 50 kilohertz. You can see compared to double of this maximum frequency, this is much slow frequency. But it's still, you still can keep everything here, is no anything stuff. So that's the bandpass theorem. All right. So if we go back to our case, what if you don't have a multiple times of this frequency, of this bandwidth? So the bandwidth in this question, the bandwidth is 67 minus 50, which is 17K. Okay, and we use the upper frequency divided by this bandwidth. We can find that N1 equals to a how much is that? 67 divided by 17 is 3.9 times. Okay, more than 3 times not enough for 4 times, so it's not an integer. What can we do? The idea is actually we can assume this one have a wider bandwidth. Okay, we can assume this signal have a new lower boundary, lower frequency, FL hat. Okay, so we're gonna have a new bandwidth B hat. So we can only extend this bandwidth. We can't, reduce the bandwidth, because we may have useful information at 50K. If we reduce that, like increase the lower boundary, some information may lose. But if we extend, that's okay. We just sample a little bit more than necessary. That's all good. So if you want to do that, you want to extend that, you want to have a larger B than current 17, then this one must round down. So we're going to round it down to 3. Okay, so if we have the multiple is 3, then what is the new bandwidth? The new bandwidth is the upper limit divided by the new n, 3. Okay, is 3 times. So this one equals to, you use 67 divided by 3, then you get how much is that? 22.3K. Okay, that's the new bandwidth. And if you are looking for the new lower boundary frequency, is actually 67 minus this 22.3, which is a 44.66. Okay, and that's the new lower boundary. So this one is 44.6 instead of 50. Okay, you make it lower, but you definitely cover all the right area, which is the useful information. Then we know the new bandwidth. We can find the sampling frequency, which is just double the bandwidth, which is 44.6K. Okay, double that value. All right, so we got this one. You can see 44K, 44.6K, much better than this 134 if you use the conventional sampling theorem. All right, so that's all for this question.